Hey folks, super excited to be here talking to you about machine learning and how you can leverage some of the different offerings that we have in Azure to sort of train and deploy models. So with that, let me just jump into the session here. So again, my name is Luis. I am a program manager on the .NET team working on machine learning and AI. And if you want to contact me, here is the contact information. You can just find that on my site. So what we're going to be talking about today, first of all, we'll sort of level set, talk a little bit about what machine learning is, AI, that sort of stuff. Then we're going to get into machine learning and how you can do machine learning in .NET. Then we're going to get into some demos, how you can train machine learning models for different types of tasks using ML.NET. And then last but not least, we'll do a quick introduction to Azure Container Apps and how you can take the model that we just trained and deploy it into Azure Container Apps. So with that, let's get started. All right, so some terminology. You may have heard different terms being tossed around, such as artificial intelligence or AI, machine learning, deep learning. So how can we make sense out of all of these terms? Well, they're all kind of related. They're sort of subsets of each other. So if we look at AI at a high level, that's sort of the overall umbrella here. And AI generally means just automating tasks that are normally performed by humans. So an example of this could be, for example, classifying spams or setting rules for your email inbox, right? So you are going through the process of applying some sort of labels or tags to your email inbox. And then after the fact, anytime an email comes from a certain person or the subject headline says something, right? It will automatically be categorized for you based on the criteria and the rules that you sort of defined. Now, in that case, AI is not necessarily doing anything smart. You're the one who's telling your email inbox or your email program how exactly things should be classified, right? So you're defining what the rules are. Now, that works fairly well, but after a while, you may find that it's very difficult to sort of write a whole bunch of if statements to try to perform some of these tasks. So you like to do a little bit better and you like to automate this process a little bit more. And that's sort of where machine learning comes in. So with machine learning, instead of you being the one that defines what the rules are for how things should be categorized or how certain tasks need to be performed, you leverage data, historical data, and representative samples of the data that you're going to be working with. And then you use algorithms on that data to try to find patterns from it. And then from that, you create a model, and this model contains the rules that it's learned based on the data that you have given it. And then last but not least, deep learning, which is probably what you've been hearing a lot about lately with sort of these large language models, right? It effectively is a subset of machine learning, and it does a lot of the same tasks. The difference being is that it uses different types of algorithms known as neural networks, specifically deep neural networks, okay? So now that you have some of the terminology down, what exactly can you do with machine learning? Well, there's actually tons of stuff. And this is actually where you often first start when you're getting started with machine learning is, well, I have a problem. Maybe AI can help me here. And so if we were to look at on the left-hand side here, there's a few examples of problems that you might have in your business or organization. For example, if you're an e-commerce site and you have a bunch of reviews, maybe you'd like to classify the sentiment of those reviews to get an overall sense of how do people feel about my products or about my company. All right. Similar with predicting ratings, forecasting sales, recommending products, identifying objects and images. These are all examples of things that you could use machine learning for, and there's tons of others. And on the right-hand side, these are examples of the machine learning tasks that these typically map to. Right. So for example, in the classifying reviews example, it's a classification task for predicting ratings because you're working with numerical values. That's sort of regression, right? And typically that's how you go when you're trying to evaluate which sort of task or how do I go about building machine learning applications. It's you have a problem that you identify and then you try to map that back to some sort of machine learning related task here. So now that you, for example, identified a problem, which is, again, the first step here, what exactly does it take to build a machine learning application? And at a high level, this is the machine learning lifecycle. This is typically divided into two phases. One is the model training, which is what we're going to be doing in the first part of this talk. And then model consumption, which is I have a model now and I would like to deploy it so that others can consume it and actually start using it to make predictions, so on and so forth. All right. So If we look at the model training phase first, again, it starts with identifying the problem. What sort of problem do I have? Can I solve this with machine learning? And if so, more or less, what does this map to in terms of a machine learning related task? Once you sort of have that, then you go through the process of collecting and preparing data, which is extremely important, right? So data is at the center of all of this. So if your data is not representative, if it's incomplete, if it's actually not helpful to solving the problem that you're trying to solve, right? Then even though you could probably train a model, the how well that model performs in the real world won't be very good, right? Because it's not going to be making the predictions or actually getting the correct results here. Right. So collecting and making sure that your data, that you remove nulls, that your data is balanced, those sorts of things, that's what you do in this collect and prepare data phase. Then you get into the model training and evaluation phase. And so the model training is basically now that you have identified your problem, you have your data, and you know more or less which task it is that you'd like to use to solve your problem, right? So that's classification, regression, so on and so forth. You try different algorithms to see which ones sort of perform the best, right? And so you train an algorithm on your data, and then you evaluate it to make sure, does my model perform the way that I would expect it to? And this is not a sort of a one shot sort of process, right? Like you iterate on this, and as you evaluate your model, you may find, well, maybe this data isn't useful to my model, or maybe this algorithm itself is not, particularly useful. And so there's a repetitive process that you go back and forth on until you land on the model that that you feel comfortable with, and that you feel and have verified actually performs as it's supposed to. Here, right? So once you're done with the model training phase, it's time to productionize that model. And so that's what we're going to talk about in the second half here with Azure Container Apps. But the model essentially is just a serialized file, which contains the patterns that it has learned throughout the training process. And so with that file, you can then just use that inside of web applications, desktop applications, wherever it is that you want to sort of use it and deploy your model inside of, you can certainly do that. And in inferencing, that's just a step where you're using the model to actually make predictions. So now that you have a general idea of what AI and ML is, what the process is for building apps, what types of problems you can solve with machine learning, let's take a look at how you could use machine learning in .NET. And so a place that you might want to start is by asking yourself, what am I trying to do here? So if you want to use a pre-trained model, meaning that somebody else trained a model on a set of data, and all you want to do is focus on that consumption phase, you're not too concerned with the model training aspect of things. A way that you can leverage pre-trained models is cognitive services, right? So in Azure, you have a suite of services for speech, you have them for images, and what these services contain is just a set of pre-trained models that you can just call, whether it's using the SDKs or REST APIs, and just perform the consumption part of sort of the machine learning lifecycle. Now, one of the challenges or something that you may find is that if you have data that is unique to your business, to your organization, to your industry, right, you may run into a scenario where pre-trained models may not contain enough or may not know enough about the domain in which you're trying to use the model inside of to actually to perform well, right? And so out of the box, they'll work really well, but then once you get into sort of more niche or more specific scenarios to your use case, you're going to find that you may need to train a custom machine learning model, right? And in the .NET space, at a high level, one of the ways that you could do that is with ML.NET, which I'll talk about in a bit. And this is going to be the focus of the conversation today. So what is ML.NET? It's open source cross-platform machine learning framework for .NET, where you can train custom models, right? So you can train them for regression, classification, whatever task it is that you want to use these models for. You can essentially do that inside of ML.NET. The other thing that I sort of noted here, we'll note here, is that you can also consume pre-trained models. So if you remember, the models themselves are just a sort of binary file, right? And a serialized file. So in that case, what you can do is if you have trained a model in other frameworks like TensorFlow or Onyx, for example, or converted to a model to Onyx, you can just bring them into ML.NET and consume them as well. So this is another way that you could also consume pre-trained models. But the focus here is that you can actually make the most of this by training your own custom models. Now, ML.NET was built for .NET developers, so because it's .NET all up, it means that you can stay within the ecosystem. You can reuse your existing skills, the tools like Visual Studio that you are familiar and productive in, and sort of everything that you're familiar with. You can just continue using that. Now, when we're going through the machine learning lifecycle, you may have noticed that some of these parts were not clear. Like, for example, which algorithms are the best? Which parameters do I need to tune so that my model performs better? How do I evaluate my model? And so there's a lot of things that you need to consider as you're training a model. But one of the things that we tried to focus with in ML.NET is making that process easier with things like tooling and with things like automated machine learning, which helps, as the name implies, automate some of these sort of repetitive and difficult steps that are associated with the process. So data science and machine learning experience is not required. Obviously, if you have that, it helps, it's helpful. But to start off, it's not required. And then last but not least, because you're training in the same language and using the same tools that you're going to be using for deployment, the process of going from experimentation all the way into production is relatively easy. And I'll kind of show that in a little bit here. Okay, so this other point that I kind of want to highlight, again, ML.NET, because it's cross-platform, it basically runs anywhere, and it's built with .NET. It runs anywhere that .NET runs, right? So that could be cross-platform from the standpoint of it runs on Windows, Linux, or Mac OS, all the way to you could run this on premises, you can run this in Azure, or really any cloud. So anywhere that .NET runs, ML.NET will run as well. So what types of problems can I solve with ML.NET? And you'll see here in this list, it's basically a lot of the same things that we sort of saw earlier, things like classification, object detection, text classification, so on and so forth. And then last but not least here, I'll sort of talk about how can you use ML.NET, how can you get started? And we offer a lot of different ways for you to get started. And this is not an either or. You can, if you feel more comfortable in sort of the code first sort of environments, right? You can certainly get started with this bottom layer here, which is just an API. And this is just a set of, .NET C# APIs that you can leverage to build your applications from, beginning to end using ML.NET and then using code first. Now, the AutoML API layer sort of sits on top of this. And what AutoML does is it will automate a lot of the tasks like choosing the algorithm, choosing which parameters to tune. It can also help you with identifying what data transformations you need to make for your data before training your model, right? So it will automate a lot of those repetitive tasks that are part of the model training phase of the model machine learning lifecycle. And then last but not least, we have Model Builder and the CLI, which depending on which frameworks you're working in, right, can sort of take the AutoML API and make it accessible for you to not have to get down into the code, but you can just focus on solving your problem. So with Model Builder, it's a Visual Studio extension that you can use to train your machine learning models. And then the ML.NET CLI, if you're on Windows or any Unix environment like Mac OS or Linux, you can leverage the ML.NET CLI again, to train these custom machine learning models here. So with that, let me jump into the demo of training a model to predict a star rating for a review, right, or product review. So let me kind of pull up Visual Studio here. And you're going to notice what I have here is just a C# class library. And what I want to do is I want to create a machine learning model. So to do that, we're going to be using some of our tooling. In this case, it's going to be Model Builder because I am inside of Visual Studio here. So if all I need to do is right click on my project here, this is my my class library, and then just click Add Machine Learning Model. Now, what this is going to do is it's going to ask me to provide a name for my model. And then we can certainly go ahead and do that, review model. Okay, and you can notice here that there's this mbconfig file or mbconfig extension. That essentially is just a way for us to store state and configurations as you go through the process from loading your data all the way to training and consuming your model. So that's what this file is for. Now, in a second here, what's going to happen is Model Builder is going to launch, and it's going to pop up a few scenarios. So you're going to see here that I now have the option to choose which scenario, and there's a brief description. So for example, here, if I want to classify tabular data like flowers based on their different measurements, I might want to use data classification. Or if I'm trying to predict things like the price of a house, I might be using value prediction. We also have computer vision scenarios, again, like image classification and object detection. And most recently, we've introduced these different natural language processing scenarios, such as text classification and sense of similarity, which are actually based on transformer-based architecture. So all of these computer vision and natural language processing scenarios, they're built sort of using the sort of deep learning models, right? And so in this case, I'm going to choose value prediction because the thing that I'm trying to predict is a star rating, a numerical star rating, which most closely aligns with this value prediction. For environment, in this case, we only support local CPU, but you're going to notice here that for some example, especially those that are a little bit more resource intensive, like those deep learning scenarios, not only can you use sort of local scenarios, not only can you use GPUs, but you could also use Azure as well, right? So you can use Azure as sort of your compute engine for training some of these deep learning models that we provide here. So in this case, local CPU is the only option. You're going to see here that this is that data loading and preparation step. In this case, I can choose either loading my data from a file or from SQL Server. If I go to browse here, I'm going to pull up a subset of my data, and you're going to see here what that data looks like. And so what I have here are just 1,000 reviews for fine food, right? And you're going to see here that there's information such as product ID, user IDs. There's information about the score. That's basically the star rating that we're going to be looking to predict. There's also information, a summary, like a title for the review, and then the text, which is just a free form text for the review. Okay. So now that we can see what our data looks like, let's take a look at what we want to predict. So in this case, I want to predict the score. That's the sort of the star rating we're looking to predict. And by default, it's going to use everything here, that every single column as a feature or as input to try to determine the relationships between these inputs and the star rating. Now, not all of this data is useful. So what I can do here is I can click into advanced data options, and I can configure a few things. So for example, the ID, things like product IDs, profile names, this is not really useful to me. So I can just go ahead and ignore those. And I'll do that for pretty much each of them. You're going to see that the score is already marked as a label here. It's the data type is single. You're going to notice that you have a few options here to choose from. And then let's ignore this last two. And then so the only things that we're going to be using here are the text, which is the free form review, and the score, which is our label or the thing that we're trying to predict here. Okay. So let's go ahead and save that. And you're going to see that already this preview sort of updates for me. And my data is basically ready to go at this point. Now, in a training step, I can choose how long I want to train for. Now, in this case, what we're using is AutoML, or the Automated ML API, to try to iterate over different algorithms, different configurations to try to find the best model for your data. So in this case, by default, it chooses 10 for me because one of the heuristics we use here is the file size. It's not a very large file, so let's go for 30 seconds here and start training. And so what's going to happen here is over the next 30 seconds, AutoML is going to go and try a different set of algorithms and configurations, hyperparameters, to train the best model for my review data set here. And it's going to be using the raw form input text as input. And the thing that it's going to be measuring the performance of each of these models against is how well it's predicting that score value or the star rating. Okay. So we're going to see here that it found one. It actually just found one. So if we would have given it more time, it actually would have iterated over even more algorithms to try to find it, to try to find more, different configurations here. But in this case, it seemed that it found one in the 23 seconds that we gave it. And then it also did a few things. So you'll notice here that here's our mbconfig file. And then if I zoom in, let me try to zoom in here just to make it easier to see. I don't think that's any better. Yeah, it's not better. But essentially, you have a few files here that are generated as sort of code behind in this, behind this mbconfig file. So one of them is this file with the mlnet extension. Now, this is that serialized file that I was mentioning, which is basically just your model, right? So now when you want to use it, you just sort of carry this mlnet file around, and you can just load that into your application and use it to make predictions. We also try to make it easier for you to either consume or train this model. So this is what I was mentioning in terms of like, it's not either or. You could start with the tooling, but then if you wanted to switch and sort of config, do a little bit more customization on the code side of things, you certainly can do that. So if we look at the consumption file here, for example, you're going to notice that we generated a few things for you. Number one is we've generated the classes that contain the schema for the inputs that are coming into the model, as well as the outputs that are being generated by the model, right? And you see here that these are show the outputs here. You're going to notice that we also create helper methods here. In this case, where it takes an input, it uses the model to make a prediction, and then it returns that prediction. We've sort of done that here for you as well. We've also included some code here to evaluate the model. So this is important if you want to understand what are the things that are impacting my model, right? In this case, it's not that important because we only gave it free-form text, but you could imagine if you were using more than one column as your input, you might want to determine what are the factors that are actually driving my model. And that's kind of what the contents of this evaluate page have here. And then last but not least, as you get more data, you're probably going to want to retrain the model on that new data. So we've given you the code here, for example, here to train your model, right? And we've also given you the pipeline or the series of transformations, as well as the algorithm that you're going to need to retrain your model on new data. You're going to notice here that I didn't have to set any of these parameters. I didn't have to tell it which transformations I needed to make. AutoML sort of just did that for me, right? And so with that, that basically just shows how you can train a model. Let me just show you one last thing. Now, one of the things that you can also do here is you can try it out. So if you give it a piece of text, it will try to sort of predict, what the star rating is. In this case, I think it was a negative review. Features for small size. And in a few seconds here, you see that it's a 2.89 star rating, right? So this you can kind of ballpark to see whether it works or not. And then last but not least, one of the other things that we'll do is if you want to sort of deploy your application, we'll sort of scaffold applications for you. In this case, you could either use it as to create a console app or a web API. In this case, what I've done here is created a web API, and you're going to notice that mbconfig file gets generated. It also brings over the model and any sort of code behind that you might need. And if we take a look at the actual application that gets scaffolded, it's just a minimal web API here, right? And a lot of this is just your boilerplate web API stuff. But the only things that I want to kind of call out here are this prediction engine pool, which is what we use to train the model. Again, we're using that mlnet file here. And then we just create an endpoint predict, which uses that prediction engine pool to predict inputs, model inputs coming in. Okay. So with that, let me kind of switch over, and I realize we're running a bit low on time here. So let me just kind of show you, now that you've trained your model, now that you've scaffolded an application or it's been scaffolded for you, how can you take this and deploy it to Azure Container Apps? So it's actually not that more difficult. So you start off where we started for training the model, right? So we started off with right-click, add, except in this case, what we're going to do on our ML API, we're just going to right-click, publish, and basically go through the process of sort of generating an application. So let me try to mock as if I was going to create a sort of container app here. So if you right click, you select Azure, you can select Azure Container Apps. You go through this process of filling out all of this here, but I'm going to see if I can skip to the end because there is something that I kind of wanted to show here. It's actually really cool. Okay, guess not. So let me just kind of go here. Let me choose my registry. Sure. All right, so this is the part that I kind of want to show you that I think is really cool here, right? So If you have an application that you're adding these models to and you already got Docker configured and you want to go through the Docker path, right? You can certainly do that with this Docker desktop option. But if you just want to use the built-in support for containers in the .NET SDK, you can just select this. You don't need a Docker file. You don't need to really worry too much about that. By selecting this, everything you sort of need to sort of package and containerize your application is going to be done automatically for you, and it's going to be handled for you with Visual Studio. And at that point, once you have your application configured for deployment, you just hit publish, and this creates an Azure Container App for you. All right. Now, if we were to go ahead and test out sort of, I have an endpoint here, Azure Container App that's running, and I wanted to test out my application to make sure it's actually performing well. Let's take a look at sending a post request here to that predict endpoint, what based on this review, what it would say. So for example, I'm telling you here that the text or the review is, this product has significantly improved my well-being. If I were to send this over to my container app that's running, you're going to see that the score or that predicted star rating is 476, right? So this is a pretty good review, and this makes sense. Now, what happens if I didn't have this sort of review here? What if I said the box was broken and there were no instructions? Would not recommend. So if I were to hit that endpoint, you can see now that the star rating for this particular review has changed, and now it's on the lower end. It's a 2.37. All right. So you can see here that training a machine learning model is not that difficult, at least to get started, right? You can just right click, add machine learning, and just go through the wizard here, go through Model Builder to train your application, to train your model using your own data. If you're looking to deploy to the web, you can just leverage some of the components that Model Builder gives you here, so that you can scaffold a web API solution, which is just going to be a web API project that's just going to be added to your solution. And once you have that solution, when it comes to deploying, you can just go through that same right-click publish workflow and really quickly, without leaving Visual Studio, train your models and then get them into production quickly and easily. So this kind of, again, sort of reinforces that sort of fact where it's very easy to go from that experimentation step all the way to production. So I'll kind of pause there and open it up to see if there are any questions.
Awesome. Thank you, Luis, so much for showing that all off. One question I had for you specifically when it comes to ML.NET, you said that you could take in other models that are out there. Can you talk about that process? Is there any standard formats that are required, or any conversions or things like that?
Yeah, totally. So some really good places. So Onyx, which is, let me just go back to my slides here real quick. Onyx here, right? So that stands for the Open Neural Network Exchange, and that is just a common format. So let's say that you're working with data scientists that are using Python for training. They can just take the models that they've trained, convert them into this standard Onyx format, and then once they have it in this Onyx format, you can just import that into ML.NET in this very similar way, like we sort of imported our models here, our standard ML.NET models. And there's a lot of different converters out there that you can sort of use for this, depending on which framework, right? Because this is dependent on which framework you're using, but there's a ton of them out there. And also there's the Onyx Model Zoo, which is a collection of models that are already converted for you. So you just need to grab the file, the Onyx file, bring it into your .NET application, and it just works out of the box.
Very cool. That's awesome. Yep. Jay says Model Builder, super duper cool, which I totally agree. And last one here for you, Mohammed is asking, how big was the data file in your example? How many rows, for example?
Yeah, so it was only 1,000. The entire file, the actual data set, it's an Amazon Find Food Reviews. It's got about 500 and something thousand. So it's like a 300 meg file, which if I would have done that as part of the demo, it would have taken forever. But the file size that I was using is just 1,000 reviews, and I think it was like a few kilobytes. So it wasn't that big, but it is a good question, right? In the sense that like the more data, specifically data that's representative of things that you're going to be seeing, your model's going to be seeing out in the real world, the better, right? So yeah.
Perfect. Awesome. And I also want to remind everyone that you can find Luis and team over on the .NET YouTube, youtube.com/.net. Every other Wednesday or so, you're doing an ML.NET community stand-up, talking about all sorts of cool stuff as well. So Luis, thank you so much. I really appreciate it.
Thanks so much.
Awesome.
Thanks, folks.
Cheers.